Hello there, geometry students. It's Mr. Zabo. Been a while since we've had a video, but we're going to go ahead and talk about section 5.7 today. In this section, we are going to be proving that our quadrilaterals are not parallelograms, but special types of parallelograms. So to get us started, I want you guys to pause the video and review some of our properties and see what we can come up with. Some of these, there are 6 figures here. You do not have to use all of the different figures the same number of times, and you might use some of them more than once. Go ahead, pause, and try these. And here we go. Number 1 is a rectangle. We know that it has right angles. That's all we know. That's a rectangle. Number 2 is a square. We can tell from the markings that all 4 of those segments are congruent, which means my diagonals are both congruent and bisected. The fact that they are perpendicular seals the deal. It's a square. Number 3 is a kite, because I know the diagonals are perpendicular, but I only know that one diagonal is bisected. That makes it a kite. 4 is also a kite. I have opposite angles congruent, one pair, and the other pair are bisected by a diagonal. That's a kite. And in 5, it's a rhombus, 4 congruent sides, opposite sides parallel. 6, opposite sides parallel, opposite sides congruent. That is a parallelogram. Now, taking these properties and going beyond a parallelogram in a proof. Okay. Key is, if it's a rectangle or a rhombus or a square that we're trying to prove, one option is to first prove that it's a parallelogram for those. Okay. And then that it has one of our special properties. So if it's a parallelogram with one right angle, it's a rectangle. If it's a parallelogram with congruent diagonals, it's a rectangle. If it's a parallelogram with consecutive sides congruent, it's a rhombus. Or a parallelogram with angles that are bisected by your diagonal, it's a rhombus. You don't have to choose to prove a parallelogram first. There are other options. We could show that if it's just a quadrilateral and we have 4 right angles, then we know it's a rectangle. If it's a quadrilateral and both diagonals are perpendicular bisectors of each other, it's a rhombus. For a square, I would need a combination. One of the things from rectangle, one of the things from rhombus. I have to prove that first it's a rectangle, second it's a rhombus. Technically, it doesn't have to be first rectangle, then rhombus. It could be rhombus and rectangle. But you do need to prove both. Okay. For a kite, remember kite and isosceles trapezoids, these are not parallelograms. So we wouldn't prove parallelogram first. For it to be a kite, we would prove 2 distinct pairs of consecutive sides are congruent. For a kite, we could also prove that one diagonal is a perpendicular bisector of the other. If it's a rhombus, both diagonals are perpendicular bisectors. Kite, only one of them. And for an isosceles trapezoid, we would need to know trapezoid first. Once we knew trapezoid, then if my non-parallel sides were congruent, it's isosceles. If either upper or lower base angles were congruent, it's isosceles. If my diagonals are congruent, it's isosceles. Okay, so we'll come back and revisit this again at another time to kind of help us go through some of our proofs here. But first proof is this. We want to prove that that quadrilateral is a rhombus. So if we take a step back and look at what we have to show, I could show that the quadrilateral has diagonals that are perpendicular bisectors. That would require me to draw in a new perpendicular bisector or a new diagonal. We can do that. I don't know if we'd have enough information here. So my next 2 options are to start by showing that I have parallelograms. That's the route that we're going to want to go here. Okay, so go ahead and maybe press pause. See if you can get to the point where you can prove that ABCD is a parallelogram first. So did you get here? Okay. We know AB is parallel to CD. So I know that angle ABD is congruent to angle CDB because they're alternate interior angles. And then given my big angles here are congruent, I subtracted. So the orange ones were the alternate interior angles I knew were congruent. We subtract and get these blue angles must be congruent then using subtraction. There's a tricky part. You have to recognize that those are now alternate interior angles of segment BC and AD. That means those must be congruent, or parallel I should say, because alternate interior angles imply that those lines are parallel. Now AB and CD are parallel because it was given, and we just proved BC and AD are parallel. I have both pair of opposite sides parallel. That makes this a parallelogram. So now, if I can go back here and show, now that I have it's a parallelogram, that consecutive sides are congruent, I'll know it's a rhombus. Or that my angles are bisected by the diagonal, then I know it's a rhombus. Well, in this diagram, I don't know enough to know if these are congruent, if that's been bisected. I have one more given though. AB is congruent to AD. Read carefully. AB and AD are consecutive sides. I have a parallelogram. My consecutive sides are congruent. That makes it a rhombus. Okay. All right. Next, I want you guys to try example 2, the last proof. And I'll give you a hint. You can do this without ever proving triangles congruent. We know it's a trapezoid. We have to somehow show it's isosceles. So remember, I want to show, so I already know this part to be true. I have to show one of these 4 things. Are my non-parallel sides congruent? Are my upper base angles or lower base angles congruent? Are my diagonals congruent? If I can show any one of those 4, I'll know it's isosceles. So as I look here, I do have both diagonals drawn, so that could be an option. Okay? But the diagonals could also give me information up here. We know that this is a trapezoid and AS and KM are my legs. Therefore, these are my parallel lines. Remember what parallel lines tells us. Okay, I'm going to give you guys a few minutes here. Go ahead and try this proof. And here it is. Okay. So I have to state that because it's a trapezoid, these are parallel. Okay. My trapezoid implies that my bases are parallel. We were told what the legs were, so that gives us the bases as well. Now I know that AP is congruent to KP, so this is an isosceles triangle. Not trapezoid yet, but triangle. So these angles are congruent. Then, because I have parallel lines, because I can see AM as a transversal, angle PAK must be congruent to angle PMS. It is an alternate interior angle pair. And if I look at segment KS as the transversal, angle AKP or PKA is congruent to angle PSM. Also an alternate interior angle pair. Well, if these are congruent to each other, these are congruent, and these are congruent, transitive property, these 2 angles are congruent as well. Now I have another isosceles triangle, which means PS is congruent to PM, and then I can add AP plus PM to the congruent segments KP plus PS, and the addition property makes my diagonals congruent. All right. In class, we're going to get a lot more practice with this, and we're going to get a bunch of practice with some sometimes always never with properties like this, and a few extra proof practice problems.